Hope y'all having a great time here at the conference. This is one of the biggest state GIS conferences in the U.S. So it's always a fun time to come here and see everybody and learn all the great things that folks are accomplishing in our industry. So I'm sure if you've been out to a recent ESRI conference or maybe a public works conference or an asset management conference or whatnot, you've heard all of this talk about digital twins, virtual reality, and all of that kind of thing. It's really kind of the growing, I guess, market in our industry as far as GIS goes, being able to do this. And honestly, it's nothing new as far as collecting data. I was telling her earlier that I started my life as a land surveyor. Not licensed, never got that. My dad was licensed, but you know, I remember early in the mid-90s going out and collecting data for the Coca-Cola bottling plant in Atlanta. They were planning a plant expansion and going inside the plant and trying to survey at the same time the plant was still in operation because they couldn't or wouldn't shut it down. So I'm out there with a total station on a tripod on these nice slick concrete floors trying to collect data, and first thing we tried setting it up and the legs went shooting out from under it, right? Because it couldn't grip the floor. So we had to build a little jig to hold the legs together, and then we're setting up, we get the thing all leveled out and go to take some shots, and a forklift tries by and the gun goes boop, 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 boop like this, and so we had to come back and reset it up and go through that, and like every 5 minutes a forklift gets. So it was like, how fast can we go collect all this data with a total station inside this plant? It took us 2 months to collect, not even the whole plant, just the area they were looking at doing the plant expansion and update. Nowadays, with current technologies, I can collect the same data in less than 2 days, right? So the technology is really getting to the point where working in 3D makes sense. You can get an ROI because we can collect the data fast enough to make it worthwhile, and more importantly, we can visualize that data. The ability to render data in 3D takes a lot of computing time, right? But now with modern GPUs and modern CPUs where we've got 12, 16, 32 cores on the CPU, we've got 16 plus gigabytes of VRAM on our GPUs, and they've got AI with CUDA cores and stuff built into them. We now have not only the ability to collect the data, the ability to use that data that we just haven't had up until recently. So being able to take your GIS into that realm makes a lot of sense. I'm going to skip the commercial for my company. You can come see me at the booth there. If my bosses ask, I gave the commercial. Okay? So, to move GIS into that 3D realm, because we've been operating in 2D since GIS was started over 60 years ago. It's hard to believe that GIS has been around that long, but it has, right? We try to represent the world in our GIS. We've done that in a 2D environment. It makes sense that we want to go more realistic and push that into 3D, because just like we said, the power of GIS is the ability to include spatial in that analysis. And that's absolutely true, but we've put it in that 2D. Now let's add that 3D, which increases the power and capabilities of what we can bring to the table with the solutions that we provide. In order to do that, we have to have an ROI. Why are we doing this? There is a certain ooh-ah factor. And I tell folks, never discount the ooh-ah factor. There is a coolness to 3D, right? No doubt about it. Really exciting, cool things. But when the day comes to an end, you've got to prove why. And now, again, because technology where it's at, we have a lot of ROIs that we can pull out. We had the opening session this morning talking about the hurricane and the damage it put in there. So being able to set up emergency response planning to go, well, if this road washes out, what's going to happen? Where do we go? Where's that, when it washes out, where's it going to fall to? Being able to model that in 3D and all that. Design work. Now they're putting back the roads that got washed out. Well, we got to be able to, where do we cut and fill that? Is the roadbed still wide enough? And so on. Just there's a lot of ROI capability now when we start looking at 3D that wasn't there before. Okay? So if you're going to take this step, move yourself into 3D, right? There's some things you got to think about. It's not just take your existing feature classes and extrude them up and you're done. Okay? There's a lot of things you got to look at. First, is your data Z enabled? If you've been building stuff or have data that was first created in, say, ArcMap or maybe QGIS or whatever solution you're working, that doesn't mean it's Z enabled. It doesn't necessarily store that. Now, if you're in ArcPro, and I reference that because it's what I'm most familiar with books on it, by default, now when you start a new feature class, it is Z enabled. Okay? So it's automatically going to be set to store Z. Now here's the question. Just because it can store Z, does that mean it really stores the Z? No. No. Just because it's set to doesn't mean it does. And if anybody's worked in AutoCAD, which is where I got started, I could do 3D drawings in AutoCAD going back, well, since AutoCAD was invented with version 1. But if you open most CAD files, what's the Z value? 0, right? So that's the next thing, is just because you can store that Z, are you storing that Z? You've got to be able to store that elevation, right? Whatever that has to be. And in addition to elevation, if we're talking infrastructure type stuff, you've also got other things like height. Right? So if I'm storing the elevation, what's the ground elevation of this building, then I've also got that height. And how am I going to do that? Part of that's also then going to be determined by your data type. Are you going to be doing just straight points, lines, and polygons? Are you going to be looking at things in a Revit model? Are you going to look at multi-patch? How are you going to store that data to achieve that 3D information? Right? So these are all things you got to think through as you're looking at pushing your GIS into 3D. It's not just a simple point click, I'm done. I mean, honestly, I can slap together a 3D scene in ArcPro in less than 2 minutes. But is it going to be accurate? Is it going to be correct? No, right? So we got to make sure that the old adage of what GIS stands for, if you're a surveyor, doesn't hold true. Right? So it doesn't just mean getting a survey. Right? We want to make sure it's accurate and good, complete data. Which brings me to this. The accuracy. Okay? Just like in our horizontal data when we're looking in 2D, the same considerations are applicable when we go 3D. How was that data collected? I have a question. I asked this because I gave this almost the same presentation in Wilmington for the North Carolina Arc Users Group. And I asked this question. I was surprised at the lack of response. What are the 3 basic types of GPS or GNSS units? Well, a total station is this unit here. That's not a GPS unit. So what are the 3 different types, range, quality, whatever you want, of GPS units you can purchase?
Survey grade.
Yep. Mapping grade. And recreational grade. So, good. So what's the difference between those? Well, their accuracy, absolutely. What is the difference? If we say it's survey grade, what's the typical accepted accuracy of a survey grade GPS unit? Sub-centimeter. What about mapping or GIS grade? Meter, sub-meter. Okay. Recreational grade. 15 feet. 25 feet. That's basically we're talking about what's on your smartphone, your iPhone and stuff. Is that horizontal accuracy, vertical accuracy, or both? It is horizontal. The average vertical accuracy is 1.5 to 2 times the horizontal. So if you're talking, I'm collecting data with a smartphone that's say plus or minus 15 feet horizontally, you're looking at 30 feet vertically. Is that good? Yeah, no. Okay? So you need to make sure you're aware of how that data is collected and to what level it's collected, right? That's where we get into things like total stations and those kind of things as well. The other thing, so just like when you go from, say, WGS 84 to NAD 83, they're horizontal datums, there's also vertical datums, right? So you've got to take that into account, because if I go from, let's see, NVGD 29 over to NAVD 88, I've got to transform or translate that datum shift just like I do with a horizontal datum. Right? If I don't make that account, then again, my verticals are going to be off. I'm going to have error in that data. So I need to make sure I'm planning for that. Which one of the datums am I going to use? Right? Now, here's another thing to keep in mind, that there is a new datum coming very soon. That NGS, USGS, and all that are working on that will supplant both NAD 83 and NAVD 88, because it's a joint horizontal and vertical datum, which means all of our state plane coordinates are going to have to be redefined based on the new datum that is supposed to come out in like 2022, and they keep pushing it out. But there's a new datum that's coming out that could change all of this as well. And then lastly, how is my elevations being reported? Is it based off of the geoid, the ellipsoid here, the geoid, which is a gravitational model of the Earth, or are we actually basing it on the true Earth surface? Right? Again, all of these things, we start looking at 3D, we have to take into account, make sure that our data is accurate, make sure things match up if I'm pulling this data in and going forward. There we go. So how do we go out and collect data? If we have to go out and do new data collection, and what are some tools out there to build some of this data if you don't already have it? Well, just like horizontal, there's a ton of different options out there. You can use existing as-builts. So if we're talking about infrastructure, maybe you've got some building floor plans. I'm working with Caltech right now to set up all of their campus in ArcGIS Indoors. We're using CAD floor plans they had. These CAD floor plans were wonderful. The most clean CAD data I have ever seen. I was very impressed. They had stuff properly georeferenced. They had stuff on the right layers. It's made that conversion much easier than I ever anticipated based off my experience working with CAD data. There. So that might be an option. You may want to go out and do new field data collection. Maybe the data you're working with isn't as current. It isn't as up to date. So you may want to go out and use things like SLAM technologies, like you see up here with this NAVIS unit. You may want to use total stations and LiDAR collection systems. You may want to use drones to go out and collect all of that. Or some hybrid model of these technologies. Right? So what's the benefits of some of these? Well, as-builts, one of the biggest pros is the data's there. You have it. It may be in an AutoCAD format, a MicroStation format, it may be hard copy files, but you already have the data. You don't have to go out and pay somebody to collect it. So potentially this could be cheaper. Right? The downside or the cons to this is it may not be complete. Right? It may not, if you're trying to look at buildings, you may not have all of the extensions that have been added, the porches. If you're doing indoors collection, because this applies to indoors, you may not have all the current modifications that have gone inside that building with new walls and partitions and stuff put up. A lot of times if you're dealing with CAD data and whatnot, it's not georeferenced. Or if it's paper, it's obviously not georeferenced, so you got to do with that. If it is CAD data, you got to do a conversion. And as I said, it's not always clean. Not everybody's as lucky as I was with Caltech in doing that. So there are some of the cons. I'm not going to get too far into this because my time is limited, but there is problems converting CAD data there. If you want to go out and field data collect this stuff, you know, the great thing with this is you control the accuracy. You're going out collecting new data. You set those accuracy specifications. You make sure it's complete and current with what you need to fulfill your goals, and you have complete control over that. The cons of it, there is cost. Either you got to pay a consultant, you've got to go buy equipment, you've got time involved in all that, so there is additional cost to consider in there. You have a lot of options, which we'll talk about here in a second. And then, how do you future-proof? You got to collect all that data. How do you make sure you've got not just enough for now, but going down one line? How do I have to make sure I've got all the features, level of detail, and all those things I need to do? And of course, you have to have access to the facilities, which may be problematic if you're dealing with some utilities or if you're dealing with like a prison or a hospital or things of that nature out there with like that. So One of the greatest technologies mentioned I could do in like 2 days is SLAM, right? Simultaneous location and mapping. So it's basically a handheld or backpack-held LiDAR unit. And here's one from Leica, here's the GeoSlam, I forget who makes that one, and here's Navis in their big backpack unit. So this one is like $100,000 to buy that unit. This one starts down in, I think $1,000 price range, and this is like a $25,000 to $30,000 price range, just to give you an idea of what these things cost. But the nice thing with this is it's portable. I can walk into that Coca-Cola bottling plant with one of these things and not have to worry about reset. I'm just walking and scanning, and something like this, I can already stick up behind equipment to get all the stuff, the mounting brackets and things like that. This is great for walking around like the street, capturing all of that information. If you're going to the Atlanta, the Southeast Desert User Conference in Atlanta next month, that hotel, my former employer, we actually scanned that hotel with one of these units and got all the way up to like the 15th, 14th floor, something like that, with one of those units. So these can be very accurate, very quick ways of collecting data. And here's some comparison if you want to see kind of the accuracy levels of these and the point densities of the LiDAR clouds that they generate. There you can see that there. It gives you kind of some ideas of what these units cost versus, or can achieve versus cost. Okay, so with that, get it down close enough here so we have open it up for some questions. Yes, sir.
So North Carolina has 2D building footprint polygons.
Mm-hmm.
They also have DMs by county.
Yep.
And then I guess you can also get the LiDAR classified by building.
Mm-hmm.
Have you ever tried to give a height value to the buildings and the building footprint polygons over top of LiDAR elevations?
Yes, you can extract that if you have the point cloud where you've got be able to get the height off that. You can pull that out and then assign it to the polygon and extrude it up. Another potential source for that is if you get into some of the CAMA data for those buildings, they typically will have like a number of floors in there, and then you can use an estimated height per floor to generate an estimated height as well. So I've done it that way today.
You don't have a script for the first methodology, the non-CAMA methodology, yeah?
I don't personally have a script for that, but I'm sure there's one out there. Or you can, ChatGPT, you tell it what it wants, it'll generate the code. I've done a lot. Some of my, I'm not, so we had a friend of mine that generated a Python script using ChatGPT that turns points into a single point into a polygon based on a certain distance, dimensions of polygons. And he did that with ChatGPT and tweaked it to get it to really work in about 2 hours. So. Any other questions?
So is the main value of this, besides emergency management, where have you seen this be applied?
So a lot of this is just building, so integrating with the BIM system, and getting a whole campus worth of that. Routing throughout, like so in Caltech, ultimately we're going to have 3D routing. So if somebody's new to campus and they're in building 72 and need to get in room 25 and they need to get to building 125 and room 6, that they'll have routing through there, including whatever staircases and things that they'll need to go up and down. Hoteling, if a lot of us remote work and maybe go into an office periodically, okay, I can reserve a desk. Emergency, like knowing where all your emergency exits are and where sprinkler systems and control systems are, there's tons of capability there. Any other questions? Okay, well thank you so much folks. If something pops up, I do have a booth over there in the exhibit hall. Stop by, say hey, and I'll talk to you some more.